Alright, g'day everyone. So this one's going to be more of a theory video. You can skip this one, doesn't really matter, but this is where I'm actually going into the schematics of the whole receiver. It's not really anything special. Like, sure, we got a power supply, it's just like filtering, basically. This is the bit that I'm building at the moment. So the first video was just this. This video is going to be explaining this, and then I'm going to do another video that probably actually shows me building it. I don't know if that's going to be valuable to people. Just watching me build a board, it's whatever, okay? You're not really going to be learning much. You'll just be seeing how I work and what my mess is like. But I want to explain just the Class A amplifier. So this bit here, I suppose we should also include our DC decoupling capacitors there. This bit here is the circuit that I'm using. Anyway, all right, this is a Class A amplifier. It has an input impedance of these two things in parallel to ground is how you consider this. So basically 1 kilo ohm. The output impedance here is 2.2 kilo ohms, which is kind of, you'll see a pattern there. And then the gain is 2200 divided by 100, so a gain of 22 voltage. Well, that would be the DC gain, but then we have this thing here. So that kind of changes the gain up to probably the maximum that the transistor can do. Now I'm going to show you how I design this stuff. So I don't design things in KiCad. This is mainly for self-documentation, because when it comes to fix this or change it, I need to know what's here already. And this is just mainly documentation. So I'll show you the tool I use to actually play around with electronic circuits. And the tool I'm using is Felstad. It's an online website. You just probably type that in. I think if you just type this in, it'll show you a few things. It's the circuit simulator. And then it's the full screen version to, make use of the whole page there. That's just a little default circuit that it shows you right at startup. It's just like a, LRC resonant circuit thingamabob. Alrighty, so I'm going to go explain this Class A amplifier. So it basically consists of a voltage divider and another transistor with a collector and emitter resistor. Now, it's not too hard to explain this circuit. The gain of this circuit is this transistor here divided by this transistor here. So this is a gain of 1, which is not very helpful, but for demonstration purposes, we'll start off just doing that. And this here is to bias the transistor. So I will draw this, connect it up, and then we can work on actually designing this circuit. Now, I would start off with, what output impedance do you want? Now, this also does set the gain. So your output impedance and your gain you have to be mindful of. I'm just going to stick with 1 kilo ohm. It doesn't really matter. The circuit here I'm using is 2 kilo ohm because I'm greedy. But we'll start off with 1K. Maybe it'll make the math easier. And for this, we will set it to 100 ohms just to make the math easier as well. This will be we'll say 10 volts. We'll just stick with really easy math here. Okay, so first up, we'll get rid of our bias transistors there. Maximum voltage is 10 volts. I'm going to have a little voltmeter here so I can actually measure the output. Okay, so this is the most voltage that the amplifier can produce. And then the minimum voltage is when the transistor is fully on, so it can go down to a volt. In this case, you've got a pretty good swing. Obviously minus the 0.6 volts across the transistor there. Now, when you set these circuits up, you need to have this node here. If this is an AC circuit, it needs to be able to go positive and it needs to be able to go negative. So we need to bias our transistor so that this here is roughly half this voltage. The way to do that is we use a little voltage divider. Or you could use, like, let's say like a 7805 and then just a potentiometer. That would also work. But I don't know, I'm lazy. You don't really need to do that when you've got a regulator supply up here anyway, which we do. All right, so let's set this up. So if we want 5 volts on this node here, then we need 5 volts across this resistor, which means we need a current of 5 milliamps. If you don't want to do the math, that's okay. You don't have to do the math. You can just use a calculator. It's fine. 5 milliamps is the answer we want. So if we have 5 milliamps here, and we know that the base current is going to be basically negligible, we should have 5 milliamps across this 100 ohm resistor. Now, that means this point here should be 5 milliamps across a 100 ohm resistor is half a volt. So if we want half a volt here, what voltage should be here? 1.1 volts. Generally, I just set this value up to like 10k, and then I play with the bottom resistor. But we are slightly low. Let's go 1.2k. 1.5k. Yeah, it's a little bit. 1.2 is probably fine. Now, this current isn't exact, and that's fine. This 6 volts is close enough to the middle point that it's not going to be a problem. So we wanted 1.1 volts here, but we have 1 volt basically. So that means instead of having 500 millivolts, we only have 400 millivolts here. That's fine. So we've only got 4 milliamps of current. 4 milliamps of current across the 1K is 4 volts drop. So we end up at 6 volts here on the output. Close enough, that's good enough. Now we can start feeding the signals in and out. Now, you can't just chuck, let's say we have a 50 ohm load. You know, we'll just directly connect it up, and you know what's going to happen? Well, it's gone. The voltage is gone. So that's not helpful. We do need to block the DC. So this capacitor, you'll generally see it as 100 nanofarad or whatever, but the absolute value doesn't matter as long as it can pass your RF. Now, because this is a 1 kilo ohm output impedance, I'm going to actually set this to 1 kilo ohm as well. Just to match it. It makes the description a little bit easier about what's going on. Now, what we can do is we can feed it a signal, because at the moment, this is just the DC operating point. So let's feed it a signal. Now, obviously, if I make a signal generator, voltage, AC source, I guess one terminal is fine, because it's referenced to ground. Let's say 10 millivolts, and our frequency is, well, because we have that 100 nanofarad there, we kind of have to be at wonderful RF frequency, so I'll pick the best frequency to be at. I am going to go set up the simulator for 1 nanosecond step size. And now, if I just did this, obviously this would not be great. This is not going to work because I don't have the blocking DC blocking capacitor. So again, we need another one on the input as well. And there, hang on. We will let the circuit stabilize because, oh, hang on, how is this one 10 millivolts? Okay, all right, whatever. We will let it settle, and I will start to set up this as well. I want a scale of, let's say, 10 millivolts, because that's what we're feeding in, with 8 divisions. And we can start to see some stuff. Obviously, our horizontal scale's wrong. And our simulation speed's just way too fast. So, I believe it has settled. Yeah, there we go. So there's our signal. What's channel 2? I don't want to show the current. Go away. And we'll show the input as well. The input of this is just this resistor here, or it's this resistor here. So, add new scope. Oh no, existing scope. We'll show that on the same scale, so 20 millivolts, and we have to AC couple it. So we'll let that settle. There we go. Now we can see our input and our output. They're both on the same scale. The gain here is 10, but if I show the, I need to find this. I think I want the peak-to-peak voltage would probably be the way to go to explain this. Let's go, because it's not RMS, because this includes the DC. So we'll go peak to peak voltage. 20 millivolts peak to peak, 10 millivolts. Oh, okay, of course, yes. So that's Yeah, okay, 10 millivolts peak to peak, 20 millivolts peak to peak. So we will be in peak to peak terms, I think, at the moment. We'll have a look at what's across here, and 100 millivolts peak to peak. Now you'll notice something. This here, 92, is not 10 times this. And there's a reason for that, because there's an output impedance. This here is a 1 kilo ohm output impedance, which means when you put a 1 kilo ohm matched load across it, you lose half the voltage, which means the gain of this circuit is actually 5. So there you go. That is kind of how to understand the circuit. If you don't want to do any of this math, you basically just go into the simulator. You know what type of levels you've got coming in. 10 millivolts is actually quite a strong signal for an antenna. It could be microvolts, doesn't matter. You always need these two capacitors. They need to pass your AC signal. And yeah, this is your output impedance. It drops when your output impedance is matched, your voltage will drop by half. So there's kind of a few things. Now, let's say we wanted more gain. This is the one last problem that I kind of want to show you, and I'm going to make some room, of course. What if we wanted more gain? Well, okay, let's go 10 ohms here. What's going to happen? This happens. A problem. Getting a low value resistor on the emitter here is being greedy. And you can't just chuck low values of resistance on. Your current will go through the roof. The power of this will be crazy. So this will heat up, or this will heat up. This low value won't, because it's low resistance. But your transistor will cook itself, and this will cook itself. But there is a workaround. There's a way to cheat this, and I'm going to show you that. So that's the last part of the circuit. We'll let it restabilize. When it does restabilize, that would be nice. Slow time steps. All right, okay. That's good enough. What you do is take a capacitor of 100 nanofarads again, and let's say we put another 100 ohm resistor in parallel with it, and we'll let this stabilize. All right, now that it's basically stabilized, what do we see? Well, our gain basically doubled. And that's because the DC path of this amplifier is a gain of 10, this divided by this. The AC path is actually, well, this is a short circuit essentially. So it's 50 ohms because we got 200 ohms in parallel. Now, my circuit, I'm being really greedy. I want all the gain I can get. So I'm chucking 22 ohms there. So if I chuck a 22 ohm resistor there, what do we get? Well, it goes off the scale. So we'll change our... Oh, wrong one. Apologies. There we go. Perfect. So yeah, we've got a voltage of 400 millivolts peak to peak here. So that's a gain by basically, I think it's 1 kilo ohm divided by basically 20 ohms here-ish. Whatever that works out to be, it's a bit of gain. Eventually, we will hit the limit of the transistor. So this only does have a beta of 100 or whatever. It's not infinite. In this circuit, where you're only doing like a gain of 10, you can basically treat this as infinite gain. It will all act the same. But when you basically drive this thing down to 0, eventually you will hit a point where you will run out of gain. And then, no more voltage, no more gain. But I do like having some type of resistance there just to calm this oscillator down, or will calm this amplifier down from being an oscillator. I suppose one last thing to mention is the phase. You'll see that it's antiphase because as this voltage goes up, this voltage goes up, which means the current increases, which means the current increases across here, which means the voltage here goes down. So there you go. It's an inverting amplifier, just Class A amplifier. It's the building block of both the filter, the preamp, and the audio amplifier. So I'm not really going to explain the Class A amp in the audio amp. It's kind of the same thing. Again, I'm being quite greedy. 4.7, 10 ohms. Preamp here, also being fairly greedy. 22 ohms as the emitter bypass. So there you go. There's the circuit. There's the theory. I guess I'll do another video where I actually build the thing. Yeah, I think that's pretty much all I have. I guess because I am going to skip the audio amplifier video, there's one more thing I want to explain. But I might do this. I might do this in the mixer build, actually. This will be part of the mixer video. Very, very simple circuit. You could probably see what it is, but I'll explain in another video. All right, 7.3 all. There's this project is on GitHub, by the way. I do have the link down below in the description. It's not very useful. It's just my idea that I want to put into practice. And ideally, I copy the audio amplifier and we'll copy this stage, have another output, and hopefully I've got 2 coherent antennas. Let's just hope the sound card's coherent. I've got one coming. All right, 7.3 all, VK4 Delta Lima.